Hi, this is Chandana. We are Group 2. We have Ashwant on call. Thank you for joining us today, Ashwant. Could you start by telling about yourself, about your role at Nokia and your experience with the present role, which what you're doing
Yeah,
right now?
sure. Yeah. Hi, Chandra. Yeah, thanks for having me. So as of now, I'm currently working in Nokia as a QA automation engineer. So back then in 2023, so I completed my internship. Then I moved. I retained as a full-time employee. Then I moved to QA automation. So we have a couple of products in Nokia which I'm working on. So one is which is more of a monolithic based, and one more thing is more of a microservice architecture because the world is evolving through all the microservices, this Kubernetes and Docker, all those stuff. So I work closely with the microservices, and I have a background in network protocols. We have a couple of protocols, L2 and L3 protocols and multicast and unicast protocols, and I work with the L2 VPN and L3 VPN services. So basically, the languages which I am working currently is JavaScript, and see all my product is all about REST APIs. REST conf. We use the REST conf interface to hit the endpoints. So we use REST APIs, and we automate those REST API test cases using a Mocha JS framework. That is nothing but the framework which is used for automation. And yeah, not only Nokia routers. We manage multi-vendor routers, aka Cisco, Juniper, Huawei, Ciena, whatever routers we have, right? So whatever, if the device supports model-driven configuration, we manage all those in our product named NSP, Network Services Platform. Yeah.
Okay, yeah, that sounds a lot like your role is really like dynamic, I can say. So we've been learning about Kafka. This is a the big data course, and we've been learning about Kafka in our coursework. So how do you see Kafka is fitting into your network data processing, and have you worked with Kafka before
Yes.
or right now?
Day to day, we will work with. We are working with Kafka right now, and we'll enhance few of the Kafka parts in the future also. But Kafka, right, when it comes to Kafka, it plays a major role in handling the real-time data streams. So basically, imagine you have a couple of applications. One is a monolithic based, one is a microservice based. Let's say you are pushing all your data to the one of the broker. See, Kafka is kind of message broker. You create the topics and you push all your data to the topic. Let's say the third party apps, you have your application, but but the another application needs your data. So instead of getting from endpoints all those things, you can just directly push whatever data required for the other application in the Kafka topic, so that they'll consume from there. So basically you'll be a producer, and the other application will be a consumer. So like this the Kafka works. It's kind of message broker. So whatever the telemetry data, basically the statistics, right? Routers basically provide results and statistics. Basically, it's a statistical data. So when router provides a statistical data to a Kafka topic, so the northbound interface lies on the Kafka topic. When you can just hit that Kafka topic, or you can just create your own Kafka topic to listen to particular uh, streams. Let's say you are pinging one router from one place to another. All the pings works with the ICMP protocol. You can subscribe to the topic where ICMP protocol. You can just give a filter named ICMP so and so. So when you subscribe to that particular topic, all the ping data will come, and you can use that data. So Kafka plays, yes, it plays a major role in real time. We do have a RabbitMQ as a message broker also, but compared to RabbitMQ, Kafka give 99.9 percentile of data efficiency. So that's the reason we use Kafka in our product. So it's more. It works with more scalable aspects also.
Okay. Thanks for letting us know about how Kafka is really how have you been using Kafka. So, oh, what about Hadoop? Like, is it something your team or you use it to handle the storage data, large data sets?
Now, when it comes to Hadoop, basically we have few other teams which uses Hadoop as a data storage, or it is storing the large number. We do have a vast number of data, right? So vast number of data can be stored, or the historical data can be stored in Hadoop. So basically, when it comes to Hadoop, Hadoop is very relevant for storing historical data due to its scalability or cost efficiency. At Nokia, we have few teams which use HDFS, that is nothing but Hadoop distributed file system, I mean, to achieve the large volumes of telemetry data of batch processing. I mean, it processed via batches. And the long-term analysis, although I focus, I mean, because my role particular to more on the automation side, and we deal with microservices and a basic of Kafka, but Hadoop we never use. But yeah, we do have a few teams which Hadoop uses to store all the historical network data. And let's say if you want to predict how the network will be in future a week, so that world is evolving again, the AML concepts are coming, all those things are coming, right? So you can store all the large vast number of data from past couple of years or 4 years, and based on the data you can do whatever you want. I mean, you can just take a test data and you can train it, and you can, based on the AML models, again you can uh, expect, I mean, how it works from the, I mean, in the upcoming years. So that may useful.
Okay, okay, that's nice. So, as we speaking of data analytics, so
Yeah.
what tools do you use for visualizing your network performance, let's say?
Sure. As I mentioned, we have two products, right? One is a monolithic based. So in the monolithic based, we haven't used much the data analytics tool or data visualization tool. When it comes to the microservices application, whatever we have today in Nokia, the name is NSP. So we use Prometheus for storing the metrics, and the Grafana dashboard to visualize those metrics. So basically, Grafana is one of the tools we use for data visualization. See, whatever the streaming data we got from networks, right? Or we got from a network or a network topology. So we each and every application will have their own metrics, or each and every application will open a TCP port and define their own metric endpoint, so that whatever metrics is coming by application, let's imagine you are running a test between a router A and router B. So basically, the test between A and B, when you execute a test from here, so all the statistics, whatever you are getting, so all those can be stored, all those metrics can be stored in Prometheus. So that can be accessed via PromQL. I mean, like we do have today database like SQL and MongoDB, right? So basically, Prometheus also can be used for storing metrics. We call it as metrics here in Prometheus language. You can query those using PromQL queries, and all those metrics, again, if you want to see those metrics, you need some nice dashboard. So you can use the Grafana, which is open source, and you can visualize all the data, whatever the streaming data here in the network. And when it comes to the data analytics tools, and we have one more Power BI tool which we use. I mean, not we, our managers use. Basically, what they'll do, right? So all our Jira tasks, whatever the subtasks assigned to respective employees, all those tasks they'll track it via Power BI tool, and they'll store all the data for all the employees, and they'll just, if they want, suddenly they'll just open up the Power BI dashboard, and if they want to search my name, they'll search for my name, and they'll get a list of the tasks. So that is how the Power BI and the Grafana is getting used in
No,
analytics.
okay, okay. So let's move on to the next question. How do you manage automation in your role? Like, can you share examples of the scripts or whatever you've been doing?
Sure, sure. When I was an intern in Nokia, I have written scripts which can be helpful for day-to-day activities. In basically, when I was an intern, right, I used the languages like shell scripting and Perl and Python. So these three languages I was more focused on. So whatever activities, I mean, I feel like automating, okay, if I automate this will help day-to-day activities. So usually I automated them when I was an intern. Then later when I moved to the, I mean, when I retained as a full-time employee, right? So it's more of a product automation. So as I mentioned, our product is all based on REST APIs or REST endpoints. So we'll automate those using our JavaScript. As I mentioned, JavaScript is the language we use, and the framework we use is the Mocha JavaScript, Mocha Chai JavaScript framework. Excuse me. So that is the framework we use for automation. So when it comes
Yeah.
to examples, let's see, whatever we do on the application, or creating a test, executing a test, or getting the results, getting the stats, monitoring the Grafana dashboard, or whatever, whatnot, and whatever we are doing in the real time or in the application day to day. So we are just replicating the same in the automation level. So that's the scripts. That's those are the scripts we wrote here.
Okay, okay. So,
Automate.
and also like curious about the role of microservices in your team. Like, how do Kubernetes and Docker contribute to scalability?
Okay. So when it comes to microservices, right? So as I mentioned, the earlier product, what we have is a monolithic based. Monolithic in the sense it's tightly coupled. I mean, the client and server will be in the same machine. Imagine you want to change a little bit, small piece of code. Let's say a customer raised a bug today. You want to fix it before tomorrow morning. So you'll fix it. But again, you have to patch the whole application to the customer, and more of a monolithic based. And as the world is evolving towards the microservices, all these Docker, Kubernetes, and Helm charts came into picture. Let's say you write an application. It's not basically tightly coupled. You write a front end, back end. You have a DB. You have everything. So make front end as one microservice. I mean, you just ship every application. I mean, you can write a one Docker file. Using the Docker file, you can create a microservice by writing the YAML file of Kubernetes, and you can deploy those pods. Kubernetes, in Kubernetes world, we have a name called pods. So you can deploy those pods using a Helm chart. So as I mentioned, so you write a front end code, you write a Docker file, so that you'll get one image, and you publish that image to the registry. From there, you can pick the image and you can write a YAML file, so that if the image is not there, you pick it from there and you create a pod, and you can deploy that pod through the Helm chart. So this is how the microservice world works. Let's say, as I mentioned again, if you want to any fix any bug, you don't want to touch all the application. If there is an issue in front end, you fix it and you ship it. So that anyhow, we have a Helm chart concept, right? So the Helm chart basically works with the version. Let's say today your app version is 12. You fixed a bug, you ship that to the customer. The latest version will be 12.1 or 12.4. So instead of changing everything, you just get the latest Helm chart. You just uninstall whatever you have today in your system, and you upgrade to the latest Helm chart. I mean, this way the more it will be more easy, right? I mean, it's a tight, when you talk about monolithic, it's kind of tightly coupled. So that's the reason the world is moving towards the microservice architecture based. And one more reason is microservice can handle more number of scalabilities, because all our networks will have so many thousands of routers. So it has to manage by a single application. It's technically not possible. It will be possible, but again, microservices have their own thing. So that's the reason we are moving towards microservices.
Okay. So let's move to the other question. So nowadays, data quality is like very vital in big data systems. So how do you maintain data quality in your scripts or in your code?
Okay, when you come to data quality, right? I mean, so essentially, whatever we have today with the telemetry data, there is nothing but the statistics. So that can impact all the network sites. So we use all the validation checks to maintain the data accuracy and consistency. For example, let's say if I'm incorporating a schema validation into my scripts to ensure incoming telemetry data, it has to expect to the proper formats. I mean, otherwise there is no data quality concept. So we have, I mean, we'll include all the data duplication errors or error mechanism, whatever we need, so to prevent inaccuracies in the downstream analysis, right? And the visualization tools, whatever we have, as I mentioned, all the Grafana and Prometheus. So it has to capture everything. Let's say the coming traffic is not right. I mean, it has to go somewhere. We have to immediately capture, or we have to throw error. Okay, this is not the place you have to come. The traffic has to redirect to some other place. So we can capture. I mean, we are capturing all those things in Grafana dashboard. So everything. So that is how we maintain all the data quality here.
Okay. So what trends in big data and automation do you see shaping network management and engineering?
Okay. So when you talk about big data and automation, okay. So the real-time analytics and the cloud-based big data solutions are transforming the network management. So the streaming frameworks like Kafka, as I mentioned, I mean, we have a RabbitMQ, but again, Kafka giving 99.9%. Right? So the streaming frameworks like Kafka combined with the cloud-based storage, that's nothing but HDFS, Hadoop, as we talked earlier. So support both real-time and the long-term insights. As I mentioned, you can store the historical data in the Hadoop, and you can use the data for AML or whatnot. And automation is also becoming more. I mean, see, these days, who will sit and do all those testing and stuff? I mean, they can write the automation script and they'll run it for, let's say, 3 hours or 4 hours. They'll catch the logic. I mean, they'll catch if any errors were there. So that's the reason automation is also becoming more intelligent and moving from simple task automation, right, to predictive maintenance. I mean, by using big data and machine learning, networks can self optimize. It's a trend that will redefine the network reliability and performance in the upcoming years.
Okay. So, with your experience in network engineering and in even big data, what advice do you offer students like us who are interested in these particular fields?
See, when it comes to network engineering, right? So basically, you have to learn how the routers work. So you have to learn the how the routers work, how the traffic will transfer from one router to another, and how the services are, how the VPN services are working. So you may I mean you can learn that if you want in the core networking background. Let's say if you don't want the core network, you just want to understand the system architecture. It's a kind of, I mean, how are you designing an application? How can you write a code? So all those things, right? So basically, the trending language today is Golang, because all the microservices were written in Golang language. I mean, although we have a Python, C++, which were old, and Java. So they're still upgrading the Java from one version to another version. They're bringing new things. But again, see, when it comes to Python, see, Python is very reliable, and anyone can write the code in Python basically. So it's a little bit easy compared to all other languages, right? Java basically whatever you write a code, it's a kind of batch. You define classes in each and every interface. You call class from there and you write a logback conf files, whatever you want. You define the log levels, so you can do whatever you want in the Java. I mean, you can do in Python, but again, when it comes to big application, huge application, which manages the more number of data, scalable data, they prefer Golang and Java when they prefer the language like Golang and Java. When you want to store the big data, you can use Hadoop. And again, if you want to stream the data, or if you want to get the topic, I mean, if you want to get the data from somewhere or not bounds, so you can use a Kafka as a message broker, so that you can produce, and another application will consume those data. And I'll suggest you to work on the projects more often, because if you want to implement any mic, I mean, you can write one any management system. Let's say today we have Amazon, right? You can just write a code for order management system, where you can just place the order, whatever orders you've placed. I mean, first imagine you have a login page, you enter all your details, that will get stored into a DB. You grab few things from the website and you place it in a cart, and you just check out, you just ship it. So all those things you can write a Java based application, but how that application can be turned into microservice is the big challenge. So you split into the parts. I mean, you write a front end using whatever technology we have today, trending technologies like JavaScript, Angular, or React frameworks, whatever we have. So you write application, you define an endpoint here, you write a backend code in Golang or Java, whichever language you feel comfortable. You define a DB, whether it is SQL or NoSQL DB. So you basically split the parts of an application, and you write a Docker images, you publish to a registry, and you get the YAML. I mean, you write a YAML file to get those images, and you create a pods. So I mean, again, it's all when you talk about Kubernetes, right? It's a huge, vast concept. I mean, again, the network come into picture in Kubernetes architecture also. But overview, I'm saying, so you can work on a project. You can mimic the real world scenarios, and it will prepare you well for a career in network automation, as well as the system architecture, or your development side also.
Yeah. Yeah. Thank you for letting us know so many things. We really
Yeah,
got very great insights,
yeah.
and hope you hope we'll meet someday or we'll
Thank you.
catch up again sometime.
Sure.
Yeah,
Yeah.
yeah. Thank you, Ashwan. Thank you for joining us today. Have a good
Thank you.
day.